Hello everyone, I'm daxim from Vienna.pm, and my talk is going to be about our boilerplate, how to make your own modern Perl dialect. I have a Google Plus blog thing. Please add me to your circles. So this is going to be a talk targeted to beginners. I don't know what the half of you experts is going to do here. You will probably be bored out of your minds. So the purpose of making a boilerplate module like that is to bundle up many common statements, use modules, use pragmas, and thus reduce the amount of tedium. And as you all know, copy-paste is bad. So instead of having something like that, or even more modules at the top of each your module or script, the point is to replace it with just one line, and then it includes the rest. To make this all work, it is necessary to understand how importing works in Perl. So what happens when you use the use keyword and then say module name and perhaps some parameters? This is internally handled as a compile time statement. Load the module. Perl translates the double colon to the separators, file path separators, and DPM extension, and goes look for a module in the inc path, and then the magic import subroutine or method is called. For example, the one module I showed at the beginning, this modules, includes a subroutine named first index, and internally the name is resolved to the full package. So when you write it like that, actually you have the full name, the package stash, which is an internal thing, but I'm not going to talk about that so much. And resolve the symbol to the code which is in the body of the function definition and subroutine. So the importing is just a mechanism of aliasing the symbol in your package where you import into to the existing one. So when you have your using code, import the function name, then you can call it by its own short name. And again, this is resolved to the full symbol, and internally they map to the same code. So what this achieves is that you can call the function of a different package with a shorter name. That's at least the main purpose. As every tool can be used and abused. And now about the import method. This is, as I said before, this is a magic thing, but it doesn't look magic. Normally all the stuff in Perl, the identifiers which do something special, also look special. The convention is to capitalize them. For example, we have the @inc array, which is the path where Perl looks for libraries, and under package under, which is an identifier which resolves to the name of the current package, and so on and so on. And it is a bit of a design mistake that import does not have did not get the same treatment. So although it is magical, it doesn't much look like that. But again, this is called automatically. Every time you use, the import method is called, the subroutine, I mean. And there are a number of things how you can use a ready-made one. For example, the in-core module exporter gives you one. You just say use exporter, and it will give you the import subroutine, which is part of exporter. And let's say we have our own custom subroutine here, which is going to be exported, and you assign the name of the subroutine to a special array variable. That is a rather crappy interface, and exporter does a lot more things. For example, you can also export not only subroutines but also variables. But this is not I consider this a code smell. So what I recommend you is instead sub-exporter, which, as the name says, exports subroutines. It has a nice declarative interface, and the name of the import subroutine is actually hidden. And it has a nice feature. What if there is a conflict, for example? In the beginning days of web programming with Perl, it often happens that you use the HTML generating subroutines from Untitled.pm. There's one called head, you know, like the HTML element, and LW simple also imports a function named head, which is the head HTTP request. And according to the order, they conflict with each other, and then Perl will give you a warning. Pay attention, you've accidentally overwritten something, perhaps. And you can avoid this with sub-exporter. There's also some special syntax where the user can decide to give, during importing, the function a different name. Everything all right so far? Okay. Yeah, another thing, just for completeness, the mirror image of use is the keyword no. So you can, as you can say, use pragma, use module name. You can also say no pragma, no module name, and it will call instead the unimport magic subroutine. Okay, so far the necessary basics. There are a number of modules to achieve what I'm talking about. Yeah, as usual, CPAN, I found 5, perhaps there are more. Thank you thank you anonymous monk on Perl monks for completing the list. And I will demonstrate one on the next slide. And in this category, also we can include modern Perl, except this is not configurable. Yeah, when you load the module, you will get the boilerplate as chromatic imagines what a good boilerplate looks like. So this is the module name of the book. Okay. Let's have a look at the API of Toolset, which is written by David Golden. So rather straightforward, not a complicated thing. Accordingly, the API is also rather clean and easy to understand. So you have your exporting module you inherit from Toolset, and then we'll give you some exposes some functionality for loading pragmas, which are special because most pragmas are lexically scoped. I won't go into details now. But suffice to say, they need the special treatment to work correctly. And for different modules, which are just the equivalent of the use statement. So when you have written formally use list modules, then with the code word operator :all, it just looks like hash key value pairs here. Now, what if this kind of code does not suffice for your purposes, or you run into a snag? Then just write your own. So the import subroutine, just write it like any other. As I said, the only special thing is that it gets called automatically. So there are passed some parameters. First the class name, which is just the current package, and the parameters. And these depend on how the subroutine was called. So in practical terms, either use or the equivalent switch for loading a module, and the import list defines how the import subroutine behaves. When you just write useful or -M module name, then parent will be empty. If you explicitly specify a list of things like that, they will also enter here. That's straightforward and logical. If you specify an empty list, this is a special case. Then the module will be loaded or required, but the import subroutine will not be called at all. Thanks. Yes, and the equivalent switch is then capital dash small letter n. This also does not call the import subroutine. Okay, now towards a more complete example. Instead of using require, which has some problems, which I can also not go into details here due to lack of time, I'm using module runtime, which exports the use module function, so it kind of works like require, only better. And the convenient thing of this is also on success returns the name of the module itself. So I can chain off the import call directly when it finishes. And as you can see here, I'm loading Perl 5i, which has some parameters itself. So far so good. And to export the stuff into the calling package, now I have to explain this first. The caller keyword or caller built-in function of Perl returns in scalar context the name of the calling module. So for example, if I have package my code, then use our boilerplate, then at this time of execution, caller will contain my code, which is the package name of the package which called this subroutine. Okay? So, and then just a straightforward string evaluation. I'm building up a string here with code and saying package the name of the calling module of the caller, and then append all the stuff which I want to load under the name of the calling module. No matter what it is named, this will work reasonably straightforward. Right. So before I explain the last bit, that was already the main part of it. Before I explain the last thing which completes the code, let's have a look at the documentation, so that I do not need to explain that much for the missing feature. So also just straightforward, use our boilerplate description. The purpose of this module is to reduce the amount of boilerplate code and enable some features that are not available by default. This is in the spirit of eliminating passivizations. I recommend that you find this article by Chromatic Online and have a read. This is more about psychology in programmers than about code itself. Switches on, Perl, moose, X, method signatures, and try catch. Okay, interface. So here's the thing which I will show right next. Okay, and to import you can pass a key named skip, and the value is an array ref of certain keywords which are described here. And if these are named, then these are not going to be imported or skipped. And yeah, this is useful for example, if you're going to write a moose roll, then you cannot load moose because it will complain them and say, hey, you cannot do both at the same time. This is a nice and easy way to switch off things to avoid such sort of incompatibilities. Right, and the extension of the code will then look rather like that. I'm going to define my features in a hash. So here are the keywords which were named in the documentation, and the value is a string of code. Again, it gets data string evaluated near the end. And here's the feature that was described with pros. If the parameter -skip exists, then delete the features from the hash. Okay, the rest is rather the same. Here I'm going to build up the evaluate string, which is going to be evaluated in a here doc, but instead concatenated all over. Yeah, and the last thing is autodial is very special. The only way to make it work like that in the caller package, I don't know why, is to first inherit from it and then later call its import method directly. Okay. Not surprised. We're hiring. Surprise is hiring. We are a technology provider located in Vienna, Austria, and our product is a full SIP internet telephony software stack, fully open source, and we are looking for Perl programmers for extending and maintaining the web panel, which is responsible for provisioning and for provisioning the customers and in the sorry, I'm too excited now. The 3 days of conference have obviously taken their toll. Okay, I have not much time to go in detail over the other modules. I will just mention a few things which we achieved by including them into our boilerplate code. After that, I mentioned last, this overloads all the built-in functions to actually not return false and error, but throw exceptions, so you can properly handle them and do not forget to handle the error, because it will fail harder, so to speak. This is a nice way to increase the code quality with just one line of code. Mostly used as a class builder, very little meta-programming going on currently, but the actual useful thing is this module, which builds on top of Moose. It includes dialect technology, which allows you to add new keywords to Perl itself, which is the thing I mentioned in the description of the talk, syntax bending. So this thing will give you a new keyword and for declaring methods, and also the methods then have advanced signatures, which meaning calling, just like other programming languages which are not based on shell. The method parameters will contain the variables which will be available in the function body. And there's also the $self variable, which you do not need to declare, will be automatically provided. And this is such a good idea that it has been implemented even a couple of times. Okay, try catch, a more advanced version of try tiny. It is useful when you have error objects of different types, and you can also return from subroutine, which is not possible with try tiny, and Perl for FI, which is a whole thing to itself. And possibly the topic of another talk of, let's say, another 20 or 40 minutes to cover everything. I'm almost out of time, but I still have time for a few questions if you, yes?
Yeah, well, both reports. In our boilerplate code, the way you handled the skip modified your static array hash of things. So if you use our boilerplate from one module with a dash skip, and then later try to use it without that, the second module will be affected by the earlier skip.
Okay, I will repeat. This was a bug report. I used our in the beginning of the boilerplate, and this is shared across invocations, right? This is you're going to say?
Well, it's file scope. It's static for the entire execution of the program. The problem was you modified the single copy. You need to make a copy of it if you're going to modify.
I need to make a fresh copy. Probably encapsulate this in a subroutine call so I get a new one each time. Okay. Questions? Not bug reports?
No questions.
Thank you very much for your attention.